And we already know what last class solve up to uh, right. So let us solve the next. So a photons with energy 5 electrons are incident on a cathode in a photoelectric thing. The maximum energy of emitted photoelectrons is 2 electron. What photons of energy 6 electron volts are incident on C? No photoelectrons will reach the anode. If they're stopping for the what is that? Photons with 5 electron volt are incident on a cathode C in a photoelectric cell. The maximum energy of emitted photoelectrons is 2 electron volt. Now, when photons of energy 6 electron volt are incident on C, no photoelectrons will reach the anode area. If the stopping potential of A relative to C is, so what is the stopping potential that we, right? What is the stopping potential? So we see that this photon with 5 electron volt is incident, right? So energy of the photon which is incident, how much is this? This is 5 electron. And on a cathode C in a photoelectric the maximum energy of the emitted photoelectrons is 2 electrons, right? So the energy which is absorbed in this photoelectron, so how much was that? So we know that this E is, or if we write kinetic energy max, right? KE max. So this is how much? This is H nu minus H, or we can also write this as E minus phi. So this is the KE max, right? So they have given the value of KE max. This is 2 electron, right? And then the energy is how much? 5 electron volt that is falling on this. So this is minus 5 on. So what is the work function of this thing? That is 5 electron volt minus 2 electron. So this is the work function, right? So this is the work function. And then what you do is that now photons of energy 6 electron volt are incident, right? So now the situation has changed, right? So what is the energy that is falling on? This is 6 electron volt, right? And do you remember the stopping potential is related with which thing? What is it related with? Yes, stopping what was the stopping potential? Do you remember? Remember what was the stopping potential?
Any maximum value of photocopying that we
Yeah. So the stopping potential was that potential. If we provide that potential, then there will be no photoelectric current, right? Because what this potential will do is that, let's say the maximum kinetic energy of the electron with which it is ejected, right? So if we provide that potential in opposite direction, then the electron will need not will never reach the other side. So that energy or that potential was called the stopping potential, right? So this Ke max, this was equal to EV naught. So this EV naught, if we provide this much energy, so then the no electron will flow in that. So that was the stopping potential, right? Right, Aisha?
Yeah.
So to calculate the stopping potential, we require kinetic energy. So maximum kinetic energy with which the electron is emitted. So that is the thing that we have to calculate. So from this information, from the previous information, what we calculated, so in the previous information, they already gave that the maximum energy was 2 electron, right? Maximum energy was 2 electron volt, and the energy which was falling on. So this was the energy which was falling, right? So we calculated the work function. So how much energy, minimum energy is needed to get the electron ejected. So this much, if we provide 3 electron volt, then electron will be ejected. And the maximum kinetic energy of the electron would be this. So from this information, we calculated the work function. Now, this much energy is falling, right? And we have the work function. So then we can calculate the maximum kinetic energy, right? So this would be how? This would be Ke max, and this would be E minus 5. So E is 6 electron volt, and minus of how much? Minus of 3 electron, right? So then what is the maximum kinetic energy with which the electron is emitting? So 3 electron, right? And whenever the energy is given in the electron volt, whenever the energy is given in the electron volt, then you can just write it in the voltage. So this in voltage, this would be simply 3 volts, right? So this would be the stopping potential, right? But if the stopping potential of A relative to C, so we have to apply the negative potential to stop that current, right? Because let's say this is, so where is this incident on a cathode C? So the photons are incident on this C part, right? And this is your A. So if this is, let's say, positive, if this is negative, then the electron will, because this is positive, this is electron, so it will be attracted, right? Because electron is a negative charge. And if this is positive potential, so then this will be attracted and it will not reach here, right? So the potential on this thing should be positive or negative. What should be the potential? Yes, what should be the potential? So this is a cathode. Okay, so this is negative part, right? This is a cathode. So if this is cathode, which means that this is negative one, and this is the anode, right? So this is negative, this is positive, and this is the electron which is ejecting. So this electron has negative charge. This is negative, so it will try to repel this thing. So the potential that we have to provide is minus of this thing. The potential would be minus of 3. So this would be the answer. Is it clear to you? So if we provide a negative potential, then this would be positive, and then this will attract this thing, and it will not reach. That is why this thing should be negative. Is it clear?
Yes.
Please note it down. Please note it down, and then we'll next. So we are carrying on with the yeah. Can you hear me, Aisha?
Yes.
Yeah. So I'll be back in a minute. Give me 1 minute. I'll be back. Yes. Noted. Aisha. Noted.
Yes.
It's now it is. Uh, and yeah. So we'll do questions more, and then we'll move on to the next. Again, the same idea that we are applying everywhere. Right? Same idea, but only there are different small tweaks in the idea, but the idea is right that we are applying every. This one is right. Okay. So a certain metallic surface is illuminated with monochromatic light of wavelength lambda. The stopping potential for photoelectric current for this light is 3V naught. Right, so stopping potential is 3V naught. If the surface is illuminated with the light of wavelength 2 lambda, the stopping potential is V naught. The threshold wavelength for this surface for photoelectric effect is what? So what we need to calculate? What we need to calculate? What are the things which are so? What are the things which are given? So we are given case one, right? Let us study the case one. So in case one, right, what we have again, we will write the same thing, Ke max. This is equal to H nu minus H naught, right? And Ke max is how much? This is E naught. This is the potential, and this is H nu. So they have written in terms of lambda. So let's write it as lambda. and this is hc by lambda naught. So what we need to calculate in this question? What we need to calculate? Threshold wavelength of this surface. So we have to find out this lambda naught. This is the threshold wavelength, right? So in case first, this potential is that they have written is 3V naught. This is 3V naught and this is HC. You can take common. So let us write it as, and then this is HC by lambda. This is one equation. Now what is the second case? So second case is what? Second case is that if the same surface is illuminated with a wavelength of 2 lambda, so again, what do we have? This is V naught, right? So this EV naught. Now for this new case, the lambda is how much? Because this would be misleading. So let's say this is V naught prime, right? Because this value is 3V naught. And this value is how much? This is HC by, now the wavelength is 2 lambda. But this thing will remain same, right? So this is the other thing. Now what we can do from here? So what we can do is that we can write this thing as EV naught, and this is how much we can take this 3 and put it in the other side. So this is HC by 3 lambda, and this is HC by 3 lambda naught. So this is what we get from this EV naught value we will get. So we have gotten this value, we will put this thing in here. So if we put this thing in here, so what we will get? We'll get HC by 3 lambda minus HC by 3 lambda naught, and this is HC by 2 lambda minus HC by lambda naught. So this thing will come this side, this thing will go the other side. So what would be that? This is HC by 3 lambda minus HC by 2 lambda. And this so this will go and become positive. So HC by 3 lambda naught and minus of HC by lambda. So how much is this thing? If we take the LCM, right, 3 lambda, 2 lambda, so LCM is 6 lambda. This is 3 lambda, so this would be 2 HC. This is 3 lambda, 2 lambda, so this is 3 lambda, 3. This would be 3 HC. And then again, this is 3 lambda naught. So how much would be this thing? This is HC minus 3 HC. How much is this thing? This is minus of HC divided by 6 lambda. This is minus of 2 HC divided by 3 lambda. So minus minus will cancel, HC will cancel, and we have to calculate this lambda naught. This will go the other side. Lambda naught is 2 into 6 lambda divided by 3. This is 2. So this will be 4 lambda. The lambda naught would be 4 lambda. Is it clear to you? Clear.
Yes.
So this would be 4 lambda. Please note it down and tell me if you have it down. Please note it down, Aisha. if you have any doubt, please ask me. And yeah, whenever you have noted that,
Done, sir.
then okay. So the next question. You can see that same formula, and it can have numerous way of right defining our problems. We're using the same formula again and again, but it has numerous right. What is the question? Okay, so a photoelectric surface is illuminated successively by monochromatic light of wavelength lambda and lambda by 2. If the maximum kinetic energy of the emitted photoelectrons in the second case is 3 times in the first case, the work function of the surface of the material. So what is the thing that we are trying to find out in here? What is the thing that we are trying to find out?
Mhm.
Work function, right? So that is fine. This is the work function, right? This is the thing that we are trying to find out. So, and again, the universal formula that we have, Ke max. This is equal to h nu minus h nu naught, which is the work function. But in here they have given the value of wavelength. Let us write that. So Ke max, this is hc by lambda minus phi naught, and yeah, so this is and let us write this Ke max 1, right? Let me write it as K1. Let us write this as K1. So this is one thing, case first. What is the second case? Case second is that now the wavelength has become, let's say, Ke max, like Ke max, and this is a new Ke max. So let us write it as K2. This is K2, and this is H nu, which is C by lambda. Now this lambda has become lambda by 2. This is the new wavelength. Minus work function will always remain this thing. So this is this thing. So K2 is, this 2 will go upstairs. So this is 2hc by lambda minus phi. So this is one equation that you are given. This is the second equation. We have to use these two equations to find out this value of phi. Right. What more information is given? So, kinetic energy, right? Kinetic energy in the second case. So, kinetic energy, more information. What is that? So, kinetic energy in the second case, that is 3 times the first case. So, we know this thing, right? So, if we put this thing in here, so if you put this thing in here, so what we will get? We'll get 3K1 equals to 2Hc by lambda minus phi. And again, if you look at this part, so K1 is given. So let us take this thing the other side. right? Or yeah, so let us keep this thing in there. So 3, K1 is how much? K1 is hc by lambda minus phi naught. If you put this value in here, and this is 2hc by lambda and minus of phi. So how much is this thing? This is 3hc by lambda minus of 3 phi naught, and this is 2hc by lambda minus of phi naught. Again, we just reshuffle this thing. So this thing will go this side, this thing will go other side. So 3hc by lambda minus 2hc by lambda, and this will become positive if it goes in the other side. C phi naught minus phi. So 3hc by lambda, 2hc by lambda, so 1hc by lambda. And then this is phi naught. So phi naught would be how much? This is hc by 2 lambda. So this would be the answer. Is it clear? Is it
Yes.
yeah? So then please note it down. Please note it down, Anisha, and then we will. So one more question is remaining. We'll do that, and then we'll jump on to the wave nature. Whenever you have noted it down, please select it. Yeah, whenever you have noted.
Done.
Yeah. Okay. So let us yeah, let us find the last type of question. This, and then we'll talk about the wave nature of. Okay, so this is a different kind of question, right? De Broglie wavelength of the emitted electron is so light of wavelength, right? Light of wavelength. So again, the idea is this, right? So what do we have? We have light of wavelength 500 nanometer. So we know that Ke max, this would be how much? That would be H and C by lambda minus this work function, right? Fine. And this is how much? So Ke max, this is Hc by lambda is how much? 500 nanometer. So nanometer is how much? 10 to the power minus. This is and then work function minus of 2.28. So 2.28 electron volt, right? So how much this thing in electron volt? So this goes upstairs. So H is how much? H is 6.63 into 10 to the power minus 34. And this is C, which is 3 into 10 to the power how much? 8. And then this is 10 to the power 9 divided by this is 5, right? So, and minus 2.28 into 10 to the 1.6 into 10 to the power minus 90. So we are writing everything in joules, right? So what is this thing? Okay, so this is how much? What would be this thing? So this is 6.63 into 3, and let us write all the tens of the orders in the other side. So minus 34 plus 8 plus 9 and this 2. So let us take this 2 upwards. So this would be minus 2. And this is divided by 5. And minus of 2.28 into 1.6 into 10 to the power minus 90. So how much is this? So this is okay, 3 3 is 9, 3 6 are 18, and then 3 6 are 18 and 19 by 5 into 10 to the power minus 36 and 17. So this is minus 90. Right? So this is 10 to the power minus 90 minus 2.28 into 1.6. Oh, so we can do this by hand. So this is how much? 5. Okay, without wasting the time, let us quickly do this using calculators. 19.89 divided by 5. So 3.978 into 10 to the power minus 90 minus 0.28 into 1.6. This is 3.648 into 10 to the power minus 9. So how much is this thing? Uh, minus 3.978. So this is 0.33 into 10 to the power minus 19 joules. This is the kinetic energy, right? But this question is somewhat right because this is related with the other topic that we have not done. So you have got the kinetic energy. So from kinetic energy, what you can calculate? What you can calculate from kinetic energy? Remember, what is the de Broglie wavelength? What is the de Broglie wavelength? De Broglie wavelength is h by p. This is the de Broglie wavelength, right? So de Broglie wavelength is related with what? This is related with the momentum. So this is the dual nature of electron or dual nature of matter. So that thing, yeah, we have not studied, but this is relating the dual nature of matter. So matter is behaving like wave and it is also behaving like particle. So this is the dual nature, right? That we have not studied, but yeah, in this question we have to use that. So this is the wavelength related to the momentum. And what can you tell about this thing, momentum? Is it related with kinetic energy? What is momentum in respect of kinetic energy? What is that? Yes, do you remember what is the relation between kinetic energy? Yes, we have to take chat box. E equal to PC. K equal to PC. This is for the right. This E equal to PC that we have to remember. So E equal to PC. This thing is how it is related. So we know that for photons, this is hc by lambda, right? And this lambda is how much? So this lambda is h by p. So for this photons, right? For the photons, this is equal. So this is applicable for photons, right? Because photons have this much velocity of light, right? But for matter, right? For matter, for electrons, we have to relate it with kinetic energy. So this is applicable for the photons, right? This is applicable. So the light is falling. So hc by lambda or E equal to pc, that is for the photons, not for the electrons and other things, right? So we can relate the wavelength of electron using the kinetic energy. So let us find out that how can we do that. So this I wanted to do in the next part, but yeah, let us understand. So we know that kinetic energy is how much? This is half mv square, right? This thing we have done already in the CBSE class. So we can write, and we know that momentum is how much? This is mass into velocity. So we can multiply this thing by m divided by m. So what will be the thing that will be? So this is m square v square by 2m. So this is mv whole square by 2m. So kinetic energy is how much? P square by 2m, right? So from this thing we can relate the momentum. So if we calculate the momentum, what would be that? Momentum would be 2m k, or let me write this as simply 2m k. So this is the momentum, and if we write it in terms of this thing, so this is root 2m k, right? So this would be the momentum and kinetic energy relation. And now we can write the de Broglie wavelength. So de Broglie wavelength would be how much? Lambda is h by p. So p would be h by lambda. So we can write this as h by lambda. Yeah, this was a very lengthy question. Why did they ask in the competition? So this lambda would be root of mk divided by h. So this would be the answer. So now we have already got the kinetic energy. We know the mass. So what we can do? So this is root of 2. Mass is 9.3 into 10 to the power minus 34 or 31. Right, that is the mass of the electron. Kinetic energy we have calculated. So that was 0.33 into 10 to the power minus 90. 0.33 into 10 to the power minus 90. And divided by h. H is how much? 6.63 into 10 to the power minus 30. So this is the answer. So okay, so again, what would be this thing? 2 into 9.3 into 0.33, and this is 10 to the power 9, 1, 10, 3, 1, so 50. This is root. So this would be how much? 10 to the power minus 25 if we take the root of this thing, and then root of this thing is how much? Let me say calculator. This was a very lengthy question. Why they asked this? So 2 into 9.3 into 0.33. So this is 6.138, and then you have to take it. So 2.477 divided by 6.63 into 10 to the power minus 30. So divided by 6.63, how much is this thing? So this is 0.3736, and 10 to the power, this 34 goes upstairs, minus 25. So this is how much? Into 10 to the power, this is how much? 9. So what is the answer that 10 to the power? Oh, okay, so we don't have any answer like that, right? So we are getting 2.8, 2 point greater than 2.8, 2.8, point. So every answer is 2.8. Okay. So every answer is 2.8. I guess we did some miscalculation, right? We have done some miscalculation and then we didn't reach the answer. I guess some some parts we have done. Oh, right. So this, okay. So p square by 2m is so this goes in here. Yeah. So this is correct. Okay, this would be the idea. We'll check the calculation later because it will take some time. But this is the idea. You please note it down, right? Please note it down, and there is some minor calculations. Did you understand this part? This was a very lengthy question. So I guess this was asked in 2015, but this will not be asked in this exam. This was a very lengthy. Is it clear to you?
Yes.
Yeah, so we calculated the kinetic energy first, kinetic energy of the electrons. And from kinetic energy, we related the momentum. So momentum was this. And from momentum, we already know the de Broglie effect. Right. So that is what. Oh, yes. 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 This is the problem. Right. Yeah. So I found the. Did you see this? Right. So this is 1 by lambda. So lambda would be h by 2. So this thing in the reciprocal, right? So whatever we have got, so the answer would be reciprocal of that. So this is whatever we are getting. Oh, then this is right. This is 1 by lambda that we are getting. 1 by lambda, this is 1 by lambda, 1 by lambda, 1 by lambda, 1 by lambda. So lambda would be 1 by 0.3736 into 10 to the power minus 9. This is 10 to the power 9. So this would be, how much is this thing? 1 divided by this. 1 divided by 0.3736. So this is 2.67 into 10 to the power minus 9. So now the order is correct. Right, 2.67. And what is the answer that they are 2.67? So 0.67. So this is the correct order, right? And we are getting 2 point, so that is less than this thing. 0.8 into 10 to the power minus 9, so we are getting less than this thing, right? So this is the correct option. Is it clear? So only the mistake was the reciprocal. Is it clear?
Yes.
Yeah, so please note this thing down. Please note it down, and yeah, this was a very lengthy problem. I don't, they will not ask this question because I used calculator and all the other things, right? Because, are you guys allowed to use the calculator? I guess you are not.
No.
Yeah. So without the calculator, we cannot do this calculation, right? I guess this would not come in here. Or yeah, you have the calculator, right? So, because that exam is online, so you have the online calculator. Yeah. We provided the calculator. Yeah, whenever you want me to scroll down the screen, please
Once.
done. Okay, so then please put down this part. Yeah, luckily we didn't do any major mistake, right? Otherwise, it would have been.
Yes.
Yeah. Okay. So the next thing that we have to talk about is yeah, and that thing we already yeah, so talked about, right? We already talked about this. So how the particle or how the light shows the wave nature and particle nature. So particle nature is represented by this photoelectric effect, right? That thing we already understood. So then what is the de Broglie? Right? This thing we have already understood. This is H by P. And we also know that the energy of the photons, how much is the energy of the photons? That is simply H. This we can relate as hc by lambda. And this lambda is again we can write in terms of p. This would be how much? hc by h by p that we have already seen. So this would be pc for photons, right? So this is for photons or light. And then we have also, so then we have power of this thing. So what is the power? Energy per unit time, right? And if we have n number of photons, then this thing will be changed to what? This would be for the n number of particles. This would be simply Ne by, right? This is capital, where n is capital. So where n is the number of particles. And yeah, so and again for particles, right? For particles or for matters, what we can write? We can write the de Broglie wavelength. So P is root to mk. That we already see. So we can write the value of the wavelength, which is h by p. So this would be how much? This would be h by 2mk. And one thing also, so this is in terms of kinetic energy. So this thing we didn't do in previous question, right? So this is in terms of kinetic energy of the particle. And what is the kinetic energy related to? Do you know? So do you remember? The kinetic energy was related with another thing. Do you remember that? Yeah, what was the kinetic energy related to? If you remember the photoelectric effect, right? So this kinetic energy was related to the stopping potential, right? It was related to the stopping potential. So kinetic energy was E P naught. So we can also write lambda is H by M. This is in terms of potential, right? So these are the things that we have to remember, and this would be all to understand all these things. So quickly note down these things, and then we'll do some questions. Please note it down.
Let.
Yeah. Okay, so now let us do some questions to understand these things. Okay, so the number of photons per second. So what is this value? Right, number of photons per second. What is this value that they are saying? This is number of photons per unit time, n by t. This is given whenever light of wavelength when it delivers. Oh, so this thing we have to calculate, right? This thing we have to calculate. Emitted by the source of monochromatic light of wavelength. Wavelength is given 600 nanometers, which is 600 and 10 to the power minus 9 nanometers. Wavelength is given when it delivers the power. So power is how much? Power is 3.3 power minus 3 watt. This is in SI unit. Will be. And H is given, which is 6.6 into 10 to the power minus 34 joule seconds. So all these values which are given, we already know that power for n number of particles, this is n by t, and E, right. So this is the thing that is given, and we also know that this power n by t, E is hc by lambda. So this thing we already know, right. We have to calculate this thing. So n by t would be how much? N by t would be p lambda by hc. So how much is this thing? P is 6.6, 10 to the power minus 30. And lambda is 600 into 10 to the power minus 9. And then what is uh, what is h? H is p into lambda, right? You have to multiply p with lambda. P is how much? 3 point into 10 to the power minus. So p into lambda divided by h. H is 6.6 into 10 to the power minus 30. And C is 3 into 10 to the power 8. So this cancels 200, this cancels 100. Okay, so now this is the order of 10. So this is 10 to the power minus 3. Then this is plus 2. Then this is minus 9. This is plus 30. This is minus 8. So this would be the answer, right? So what is this thing? So plus, let us calculate the plus plus. So this is 10 to the power 36 plus 34 plus 2, 36 minus 8, 3, 11, 11 plus 9, that is 20. So minus 20. So this is 10 to the power 16 photons per second, right? So this is the answer. Is it clear? And this has been asked recently. But this was a very simple question, And yeah, so we didn't need to use any calculator as well. So is it clear to you?
Yes.
Yeah, please note it down and then we'll be next. Yeah, whenever you have noted it down, please do. So you see that how cruel they are, right? They have written 15, 16, 17, 18. So if you miss one 10, then your whole answer would be different, right? So we have to be very careful with the orders of 10. This way we have to be very careful. Yes, whenever you have noted, please say.
No.
Yeah. Okay, so again, this is the same question that they are asking, right? So power is given and sodium street lamp emit yellow light of wavelength this, assuming it to be 25% efficient in converting electrical energy to light, the number of photons of yellow light it emits per second, right? So you have to calculate again the same thing, right? I will leave this question to you. Power is given, right? Power is given, which is 200 watt, and then the wavelength is also given, which is zero point 0.6 micrometer, And then assuming it to be 25% efficient in converting electrical energy to light, right? So this is 25% efficient, which means that only 25% of the energy, whatever energy you calculate, so that is 0.25 energy that you are getting. So energy value you have, that is also there. And then you have to calculate the yellow light. So again, you have to calculate N by T, right? So is this question clear to you? Is it clear? Can you do this problem? Yeah, so okay, so this time, yeah, we can calculate this, right? So we can calculate this E from here. So this E is how much? Hc by lambda. So use this lambda, you calculate this E, then calculate the E prime, and from this E prime you have to calculate this M by T. So what is the formula? Power is N by T, and this is E prime. So you can calculate N by T using P by E prime. So now you calculate E prime from here, P from here, and then you'll get the answer. You just note down this problem and please do this. So I will ask this question in the next class, right? But you please do this problem.
Yes.
Note it.
Yes.
And again, a source is producing this one. Okay, so a source S1 is producing this photon per second of wavelength. Another source is producing photon. Then the power by power is equal to, right? So what is the power? This would be, we know that power by power, or let us first write what is the power. Power is N by T, right? And this E is how much? So this is C by lambda. Because wavelength is given, so we have to write it in terms of wavelength. So this is Hc by lambda. So this is the power. Now P1, let's name it as n, small n. So this would be how much? This would be n Hc by lambda. So P1 is n1, h is constant, c is constant, lambda 1, and then P2 is how much? N2, h is constant, c is constant, lambda 2. So if we divide these two things, what we will get? P1 by P2. This would be N1 Hc by lambda 1 divided by M Hc by lambda 2. Hc will cancel. This lambda 2 will go upstairs. So this would be how much? This would be N1 lambda 2 divided by N2, and this lambda 1 will go downstairs. So we have to calculate this thing, right? So N1 is 10 to the power 50. Lambda 2 is 5100 and divided by producing 1.0, right? Is it the decimal? Sorry. I thought that this is the dot. Is it? What? Can you see this is this the decimal or is my screen? Oh, so this is the dot, I guess, right? I thought that this is on my screen, right? Okay, so this is 1.02 into 10 to the power 15 the multiplied by lambda 5,000. So this double zero will cancel, and 10 to the power 15, 10 to the power 15 cancels. So 51 divided by, how much is this? Multiply this. So 50 into 1.0. So that is 51. So 51, 51, that is 1. So the answer would be 1. Is it clear?
Mute.
Yeah, quickly note it down and stop at here, and we'll continue our